Okay, let's start with some exam questions regarding the product rule, a total of 3 as usual. So the first one is this one. This is from October-November 2008, question 6, and the question is as simple as this, and 7 points for it. Find the exact coordinates of the point on the curve y equals x e to the power of minus 1/2 of x, at which the double derivative of y equals 0. So what do you have to do over here? You'll have to differentiate this twice, all right, to answer that question. So let's look at it. So here you have it. This is a product of two simpler functions. The first one being x, the second one being this over here. So to use the product rule, you have to use this formula, which you can find on the MF19, by the way. Not that you're going to use it because you're going to solve so many questions that you won't need to use it anymore. No, it's not. It's here, the product rule. Okay, it's in terms of v and u. Okay, it's the same as that you had over there. So you have to identify what v and u is. So this would be u, this would be v. Differentiate u in relation to x and v in relation to x. That's what I did over here. This should be easy, right? You are differentiating an exponential function, and you already know how to do that. You differentiate the power, which is minus 1/2, and multiply by the function as is. So this is the outcome. And then when you have these four terms, just put them in the right place. That's what I did over here. I just put them in the right place. Then I factorized e to the power of minus 1/2 of x. And there you have it. The expression, the function that corresponds to dy by dx. But you want to continue and differentiate this again. So now you have a new u and a new v. The formula is still the same. Differentiate u in terms of x, you have minus 1/2. Differentiate v in terms of x, and if you look, this expression is exactly the same as you had before, so you just plug in here the result that you had before. You already have the four terms. Plug them in the expression and simplify as much as you can. Again, you have the term e to the power of minus 1/2 of x to factorize, and that's it. Okay, so this would be the expression. Now you equal it to 0 and solve, right? You have the product of two terms, so for it to be to 0, either one of the terms needs to be 0. This one can never be 0, all right? E to the power of something can never be 0, means that this is the only option. And by solving this, you'll figure out that x needs to be 4. So you know already the value of x. Substitute it on the original equation to get the value of y. And there you have it. You want the exact coordinates. So this is what you leave your final answer for e to the power minus 1/2. Another question, May, June 2008, question 6, and it says, it is given that the curve y equals x minus 2 times e to the power of x has one stationary point. Find the exact coordinates of this point and determine whether this point is a maximum or a minimum point. You solved many questions last year, just like this one. You already know what to do. In order to find the coordinates of a stationary point, you just have to differentiate the function, equal it to 0. Solve the equation for x. When you get the result, x is going to be that result is going to be the x coordinate of the stationary point. Plug it in the original function to get the y coordinate, and you have this question answered. To figure out if it is a maximum or a minimum, differentiate again the result in I, so that you have the double derivative. Plug in the value of x that you get over here. If the result is a positive value, then this stationary point is going to be a minimum. If the result is a negative point, then it's going to be a maximum. You already know this since last year. The only thing that is new is differentiating this using the product rule. So let's do it. Here you have it. Again, choose this as being u, choose this as being v, so that you can apply the formula. Differentiate this in terms of x, differentiate this in terms of x. This is what you get, all right? Plug in over here, equal it to 0. You can factorize the e to the power of x, all right? So if it is equal to 0, either this or that equals 0, you already know that e to the power of something can never be 0, so this is going to be impossible. Solve just this, and x equals 1. So you already know the x coordinate of the stationary point. Plug it over there, and you have the result minus e. So the coordinates, the exact coordinates of the stationary point is 1 minus e. To check its nature, you have to differentiate it twice. And here you can see the pattern that you could, by all means, do this again. But it's simpler just to understand what happened. Look at the expression that you got. Or where is it? Yeah, this one over here. And compare it to this one. This is the original function, x minus 2 times e to the power of x. This is dy by dx, x minus 1 e to the power of x. So what happened? Here, instead of a 2, you have or better, instead of minus 2, you have a minus 1. So if you differentiate again, this will be what? This will be 0. So this is the result. I don't even bother to or spend time differentiating. I already know what's going to happen. This is going to this term is going to increase by 1. So this is just x, right? Now you just plug in the value that you got over here, the 1. And this is going to be just e. And e is a positive number, so this stationary point is a minimum, right? One more. It's made June 2010 now. 5. The equation of a curve is y equals x to the power of 3 e to the power of minus x. Show that the curve has a stationary point where x equals 3, and then find the equation of the tangent to the curve at the point where x equals 1. All right, so to figure out that the curve has a stationary point where x equals 3, we just have to differentiate, equal it to 0, and one of the values, if you have more than one, is going to be 3. So here you have it. Again, this is u, this is v. Differentiate both in terms of x, this is what you get. Substitute in a formula, this is what you get. You can factorize again the e to the power of minus x, equal this to 0. This is going to be impossible. You basically just have to solve that cubic over here, factorize x squared, equal it to 0. Just solve as you are already used to. And eventually you get two values, either x equals 0 or x equals 3. You just have to prove that x equals 3 is one of the options, all right? Doesn't say anything about x equals 0, so it doesn't matter. So you already proved it, okay? Then in order for you to figure out the equation of the tangent where x equals 1, never mind this result, the only thing that you're going to get from the previous alinea is the expression for all the derivatives, all right, all the gradients. So what gradient do you want? You want when x equals 1, so plug in 1 over here, all right, get the value, and this is the gradient of the tangent to the original function when x equals 1, all right. So you already have one thing for the equation of the tangent, which is the gradient. You need to get the y-intercept. So in order for you to do this, plug in the value 1 on the original function, and this is going to be the y-coordinate. So you know that this point, 1 over e, is a point that belongs to the tangent. So plug it over here on the equation of the tangent. Y minus this equals the gradient times x minus that. Expand, and here you have the equation of the tangent. All right? You can just put it like this. In my opinion, it's prettier, so that's the reason why I left it like that. Okay? You could also, over here, plug in the value, where am I? Yeah, plug in the value 1 and 1 over e on the equation of the straight line to get the value of c. You will get exactly the same result.